Hello everyone and welcome back to our course. In this lecture, we are going to learn about pointers, which are very commonly used in C++, so they're a fundamental topic to know. First, let's move our if statement code into its own function. We can just call this void and then build if statements. And we can just put all of our previous lectures code in there. And then we can get started afresh in our main function. That way we still have this stored if we ever want to call this function. Okay, now let's go into main and let's create our first pointer. A pointer is similar to a variable, and what it does is it points to a memory address instead of storing a value. Because on your computer, whenever you're creating a variable, you're actually storing a box in memory. And that box has its own address. And with a pointer, we can actually point to that address of where a variable resides. For example, let's say I make a variable that I call player health and I set it to equal 100. Okay? This here is a variable and it has a place in memory. It also has a memory address showing where on your computer's memory that variable exists. This 100, that is the value. If we create a pointer, what we do is we declare the same data type, but then we add this asterisk after it. And let's call this our player health pointer. Okay, so we are pointing to the player health. And in order to assign this a value, we can't just put player health because that would be referring to the value. Instead, we have to add an ampersand or an and symbol in front of player health here. This refers to the memory address of player health. For example, I could print this out for you to show you. I will show you the value of player health first of all. Let's put that on its own line. And let's hit debug in order to see that. And what we get printed out is 100. All right, as expected. Then what if we added the ampersand in front of player health? Well, you're going to see that is actually going to refer to the memory address of where that variable exists on your computer. So now we first have 100, but now we have this string 009CFD6C. That refers to the memory address on your computer where this player health variable exists. And this variable is going to exist as long as it's used. Okay, as long as we have it declared. Now this player health pointer is just a way that we can store the memory address instead of the value. And it's used very often in C++, these pointers, because often in C++ you want to refer to the memory address of a variable instead of the value of the variable. Okay, so here I can then paste out my pointer here to player health. So let's just have our line called again to print to the console, and this time let's paste out the value of player health pointer. And pay special attention to the syntax here, because if you miss one of these little symbols, it can change completely what you get. So you have to be very detail oriented here. If I hit debug now, I get my memory address printed again. So this here, the player health pointer, that is printing the memory address, because that is what the value of the pointer variable is. All right, there we go. Now, what if we wanted to get the value from the pointer? What if I wanted to get 100 from this pointer? Well, because we've seen that if I just call the pointer, I don't get the value, I get the memory address. But what if I want to get the value from the pointer? Well, all you have to do is grab here the player pointer, and then in front of that, put in an asterisk. Okay, so that will be the value. In fact, we could store that as a variable. We could call this our pointer value, and we can just grab that pointer value to make it more clear what that means. So here we are using an asterisk in front of the player health pointer, and don't forget the semicolon at the end. Okay, here we now are storing that as just a regular integer, not a pointer. And if I hit debug, I'm going to see I get 100 as my last line, which refers to that last line here, the pointer value. So we were able to get the value from the pointer. What if we wanted to change the value of the pointer? Well, that actually would affect the original variable that the pointer was pointing to. For example, let's say I took my player health pointer, and here you'll notice I'm getting its value because I have that asterisk in front of it. What if I wanted to change this from 100 to 90? Well, I can actually directly change the value that the pointer is referring to. Remember, the pointer is pointing to a memory address, and at that memory address there's a value. And so with this syntax, I'm changing the value at that memory address. Notice I'm not going through the pointer value because that's its own separate variable. I have to go directly back to the pointer if I want to change its value. But one notice is that, remember what's being stored at that memory address. What's being stored at that memory address is the player health memory address. So by changing the pointer's value to 90 with that asterisk in front of it, we're actually changing the value of player health as well. Because remember, player health pointer points to the memory address of player health. So by changing the value of the pointer, we're actually changing the variable at that memory address. So what if I pasted out the value of player health now? Do you think it will be its original 100? Or do you think it will be 90? Because notice we didn't change this variable directly, player health. You have to be really detail oriented here. We didn't change the variable directly. We changed the variable via the pointer. So now if I hit debug, my last line is actually 90. So you see, by using a pointer, we can actually affect the variable that the pointer is pointing to. The memory address is still the same. So we can still grab the memory address of player health and the memory address of the player health pointer, which is just the player health pointer itself, because a pointer stores a memory address. And we'll see that those two are exactly the same. If we hit debug, look at that. Those two are exactly the same. So that is why by changing the value of the pointer, we actually change the value of player health. Notice that we didn't change player health pointer directly. We could have player health pointer point to another variable, such as damage, right? But then we would have to use its memory address first. So we would have to have an ampersand, and we would have to actually create damage. So we could have this int damage equals 30, for example. So you can actually change what the pointer points to. And that's totally fine. You're just changing what memory address it's pointing to. So if you changed the pointer's value afterward, you would now be affecting the damage variable instead of the player health variable. It can take some time to wrap your head around this, so the best way to learn is just to try all these examples out step by step and see exactly what gets logged in your console. Coming up next, we're going to talk about a similar topic in C++ known as references. And we'll compare pointers with references. So I will see you in the next lecture. Hello everyone, and welcome back to our course. In the previous lecture, we learned how to build pointers, and in this lecture, we're going to learn another key topic in C++ often used, which are known as references. Right, so first let's just move all of our code for the pointers into its own function called build pointers. All right, and let's go ahead and move that over just so that our main function is not so cluttered. And next we're going to create references. So whereas a pointer points to a memory address and can be changed, a reference actually points to a variable itself. And if you want to change it, you'll actually be changing the variable that it's referring to. So you can never change the actual memory address of a reference. Let's get started with an example. Okay, let's say we had here an integer called our player level, and our player was a, let's say, level 3. Okay, then let's create a reference to this variable. For that, the syntax is the data type, which has to match the variable that you're referencing, followed by an ampersand, or the and symbol. That is the data type for an integer reference. And then let's call this our player level reference. The value is not going to be a pointer. It's actually just going to be the variable itself, player level. All right. And if you paste out the values of these two, you'll see they are actually exactly the same. So let's go ahead and paste out with cout. First, player level. And let's end the line with the line break, followed by the player level reference. Let's also log that out and end the line. Then if I hit debug, I'm going to be able to see that both of those have the value of 3. So we have 3 and 3 being printed out. So that is how you can create a reference. Now, what about their memory addresses? Let's go ahead and paste those out as well. So I can just copy my 2 lines, and all I have to do is add an ampersand in front of the 2 variables if I want to be able to see their memory addresses. And look at that, they have the exact same memory address. Why? Well, because when you take a reference and you assign it a variable, you're not just assigning it some value, a copy. You're actually directly pointing to that variable itself. Next, let's talk about the differences some more between a pointer and a reference. So a pointer can be null. You could create here an empty pointer, like you could do an int here and call this our empty pointer. You could also do void empty pointer if you don't even know the value type of your pointer. So let's call this empty pointer void. And you can assign the value later. You will get a warning though if you never do assign them a value later on. But with a reference, you actually can't make that without a value. If I try to do here my reference again, but this time let's call this nothing, player level reference nothing, I'll actually get an error here. So I can't just leave it like this. A reference variable requires an initializer, which means you have to declare it with a value, unlike a pointer. Another difference between a pointer and a reference is that you can change the memory address that a pointer is pointing to, but you can't change the memory address of a reference because that is always fixed to that initial memory address. For example, here, player level. Let me show you an example. Let's say we created an int that was called damage and it was equal to 1. All right, and what if we wanted to change our player level reference to reference the damage instead? Well, we could try this out. We could try taking the player level reference and assigning it to equal the damage. But what this is going to do is it's actually going to change the initial variable itself. It's going to change player level. It's going to change player level as well as player level reference. Okay, so I can test that out just by copying these lines and pasting them again. And we can see what we get as our last 2 lines. As our last 2 lines, look at that. We get 1 and 1. So what happened was our player level got the value of 1 because that is damage, and our player level reference got the value of 1. So of course the player level reference gets the value of 1, but you may be surprised that the player level also changed because it doesn't look like we changed player level at all. We just changed player level reference. But the thing is, by changing a reference, you're also changing what variable that reference is referring to. So you have to be careful when you change a reference because you are actually also changing that variable itself. Why? Well, because a reference is pointing directly to the variable and you can't change that. I can't try to change the memory address of my reference. My player level reference will always have the memory address of the player level. It will never get the memory address of the damage. And that is how you can build out references. These are quite important to understand because pointers and references are used very commonly in C++, and we'll also see them used when we build out our games. So if you don't understand them, still go through this line by line again and use the debugger to see what is being logged out at each line. And keep practicing because the best way to learn is practice. Coming up in our next section, we're going to continue learning the fundamentals of C++ with one more section where we'll talk about how to build classes and objects, another key part, and then we can jump into our projects.